Hello, this is Mr. Henry, and welcome to lesson 1.3. In this lesson, we're talking about integer exponents. We're going to start a unit on, or a couple lessons here talking about different properties of exponents. So the warm-up says, what do you know about exponents? Can you think of an example when they're useful? So most people, when you think of exponents, you think of something just simple like 3 squared equals 9, or 5 to the third power is 125. Those sorts of things. And yeah, those are exponents. And you may even know the vocabulary, and we'll get to that in a second. But most people can't think of why they're useful. And throughout these next few lessons, we'll come up with some examples when they are useful. So here we have our vocabulary: power, base, exponent. So the power is the entire thing. It's the base and the exponent together. So the entire thing, if I would write out that, this whole thing together is called a power. Now, the base would be the bigger number that's on the bottom. So in the example I put up there, the 2 is the base. So the power is the whole thing. I'll use that same example. The base is the 2. And you can probably guess that the exponent then would be the 5. It's the little number on the top. So just kind of getting us into the lesson a little bit here, let's look at some different properties. So we're going to start by looking at properties. We're not really doing many problems of applying them. We're just looking at what these properties mean. So the first property here is we're trying to understand the product of powers property. The product of powers property, what that means, like the title, the name means, is we're multiplying powers together. So we have two powers like you see. You'll notice they have the same base, 7 and 7. So we're going to multiply these two things together. Now the way that I would think about this problem is if you would take this 7 to the 4th power and you would expand it. 7 to the 4th power means 7 times 7 times 7 times 7. That's the first part. Times this 7 to the 5th power. So 1, 2, 3, 4, 5. So that's what this same problem looks like if you expand it out. You've got 7 to the 4th power times 7 to the 5th power. But since these are all multiplies, multiply, 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 all we have to do is just think about this one long line of 9 different 7s being multiplied together, which is 7 to the 9th power. So we just simplified this exponent. So 7 to the 4th power times 7 to the 5th power is 7 to the 9th power. And there's actually a rule that can help us do this. The rule basically says if you have two exponents, we'll call it like a to the n times by a to the m. If you have two exponents and you want to multiply them together, or two powers multiplied together, if the base is the same, you add the exponent. And that's what we did here. The base stayed the same, and we add the 4 plus the 5 and got 9. Okay? And we're going to go through these in more detail. So we're just going to start by going through each property kind of one at a time, and then we'll look at using them. So this is the product of powers property. Next property here is the power of a power. So another way to write this same problem would be 4 squared to the 6th. So the whole thing is to the 6th power. So you have 4 squared, And this 4 squared is to the 6th power. So you would have, if you would expand it out again, 4 squared times 4 squared times 4 squared, 6 of them. That's 4, 5, 6. So now we have this. But this is just like the last property we just did. We have a whole bunch of powers with the same base, so we know that we can add the exponents. If I would write this out even farther, there's going to be a whole bunch of these guys. 4 times 4 times 4 times 4. There's the first one. And the second one. 4 times 4, third one. 4 times 4, fourth one. 4 times 4, fifth one. 4 times 4, sixth one. But this line, after we've completely expanded this out, we just have 12 4s. 2, 4, 6, 8, 10, 12. 4 to the 12th power. Do you think you can find a connection between the answer we got here and the problem we started with here? Maybe you notice that it looks like we might be able to multiply 2 times 6 and get 12. And the answer is you can. That is actually the property in this problem. So if I use the variables again, a to the n times by, a to the n to the m gives you a to the n m. You multiply the two powers together. All right. So let's look at our next property. This says the understanding the power of a product. So now we have a different base, but the same exponent. So let's start by doing the same thing we've done before. We're going to expand this out. So we have 5 to the 4th power, 2, 3, 4, times by 3 to the 4th power, 2, 3, 4. Now, you may not think to do this, but we're still trying to just figure out what these properties are. But let me show you a little rearranging trick that's going to make this property a bit more clear. If I rearrange this as a 5 times 3, a 5 times 3, and repeat this, so there's my 4 5s and my 4 3s. I've just rearranged it. This looks like 5 times 3 to the 4th power. And that's what it is. I mean, that's the simplified way of writing this same thing. And if we want to do one step further, I mean, this would be 15 to the 4th power. And that's just simplified. You may not have thought to do this, and that's okay. I'm showing you the property so that we can go over it. And you can see here how 2 powers were kind of combined into 1. And if I use my letters, maybe we'll call it a to the n times b to the n. Those can combine to give you ab to the n. That's just a way of thinking about it algebraically. That's what we did without the in-between work. Okay. Next problem says we're going to be understanding the negative exponent property. So in this case, the title itself is obvious. I mean, now we have a negative exponent, but what we would do is not so obvious. Now, the way that this works, or a way to think about this, is how a regular exponent, like 3 to the 4th power, represents multiplication. 3 times 3 times 3 times 3. But a negative exponent is going to think about it like it's division. They're kind of opposites. Positive 4 and negative 4, multiplication and division. So what this actually gives us, it's kind of weird. It's like 1 over 3 times 1 over 3, which in this case is just 1 over 3 to the 4th. Now this is just one way of thinking about it. It's not the only way. A way that I like to describe this is whenever you have a negative exponent, the way you get rid of that negative exponent is you pass it over the fraction bar. So let me give you another example. If we had 5 to the negative 6th, there we go. That way I can move it around. So we have 5 to the negative 6th. So if I want that negative to go away, I'm going to move it over the fraction bar. So this whole 5 and negative 6 comes down. Now, when I move this negative 6, or the whole term down, the whole power down, the negative goes away. Now it's 5 to the positive 6. And up top, we would have a 1. And that trick works forever. If I had a positive 6 down here, and I move the whole term up top, it would be a negative 6 again. Let me show you something else I made a few years back. So here I have a little flash activity I made, just kind of show this procedure. So as I take this 5 to the 6th power, now it's positive 6, and it's on the bottom of the fraction, so think of this as a fraction bar. As I take this piece and I move it to the top, the exponent changed from positive to negative. And if I take any of these pieces, this x to the negative 3rd, if I move it down, it becomes positive 3rd. 8 to the negative 2, if I move it up, it goes positive. If I move it back down, it goes negative. So you can actually change the sign of the term you're using by, I say, moving it over the fraction bar, flipping it over the fraction bar. Okay, so the way we would think about this in terms of our algebra, so if I have a to the negative n, for example, to make this not negative anymore, it'd become 1 over a to the n. So 3 to the negative 4th became 1 over 3 to the 4th. And the last, I think this is the last property for us to look at is the zero exponent. And this one's simple. The zero exponent basically tells us that if you have anything to the 0 power, if you have x to the 0, if you have negative 3 to the 0, if you have 97 or 19 to the 0, any number to the 0 power equals 1. Every single one of them. So a to the 0 power equals 1. And we can think about this with some of our other properties we used. For example, that first property we learned about. Imagine we had 3 to the 5th power times by 3 to the 0 power. Well, the bases are the same, so we would add the exponents. So 3 to the 5 plus 0 is still 5. So me multiplying by this 3 to the 0 power, that did not change my answer. It's almost like saying if I took 3 to the 5th power times by 1, I'm still going to get 3 to the 5th power. So that's another way to show this something to the 0 power is 1. Now, this chart here is just kind of to show some of these different properties. It doesn't show all of them, but it kind of helps you see a pattern. So we'll start here at 5 to the 1st power and work our way up. So 5 to the 1st power is 5. That's just 5 times 1. 5 to the 2nd power, 5 times 5 would be 25. 5 to the 3rd power, 5 times 5 times 5 is 125. 5 times 5 times 5 times 5 is 625. So you notice how we're getting bigger, bigger, bigger going this way. Going down, well, we just said that anything to the 0 power is equal to 1. And now we have negative exponents. We know that if we have a negative exponent, the way we get rid of that negative is we pass it over the fraction bar. So this becomes 1 over 5 to the first power and 1 over 5 to the second power, which is 25, 1 over 5 to the third power, which is 125. So we're getting smaller the more we go down. Another way I've just thought of about thinking about this is every time you go one step bigger, you are timesing by 5. I mean, think about it. 5 times 5 times 5 times 5. Even starting down here, if you start at 1 over 125 and you times by 5, you're going to get 1 over 25 times by 5 times by 5 times by 5. Going the reverse, going down, is a divide by 5. So 625 divided by 5, 125 divided by 5, divide, 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 divide. So that just kind of helps you maybe imagine or picture these exponents in your brain to help you when you're doing some of your problems. Now, up in your vocabulary box on the right-hand side, there's a section for these properties, and I'm going to just give them all to you right here. So these are all the properties we talked about. The first one is the product of powers, and you can see it's the same property I wrote down. A times n times a to the m equals a to the n plus m. That's where you added the exponents together. The power of a product, that's if you had like a power raised to another exponent, so like 3 squared to the 5th, you would multiply the exponents and get 3 to the 10th. Power of a product property, if you had two different bases with the same exponent, you can combine the bases together, like there. The negative exponent property tells you if you want to make that exponent positive, you pass it over the fraction bar, so it goes from being a negative to a positive, or I should say a negative on the top of the fraction is positive on the bottom, and the reverse is also true. If it's negative on the bottom, it will be positive on the top. And finally, the zero exponent property tells you that anything to the power of 0 is equal to 1. If you need more time to copy these down, pause the video, but I'm moving on. So now we're going to actually look at some problems. We're going to use these 5 properties to simplify problems that have exponents. Some of the problems are going to be kind of ugly. For example, here it says simplify each expression. Answers should be expressed with only positive exponents. And you're going to see that phrase a lot. Typically when you're dealing with exponents, you want your answers to be positive exponents. Okay, so let's go. First problem here. Well, I see I have the same base, 6 and 6. So eventually I'm probably going to be combining this stuff together, but this first part looks a little ugly. I've got to do something with that first. So I'm going to take 6 squared to the 4th power. Let's think back. I have a power to a power, which means I multiply them together. Okay, so that's going to be 6 to the 8th times 6 to the 3rd. Now my powers are being multiplied together, but I have the same base. So I can add the exponents. So it's saying I have 8 6s here and 3 6s there, all multiplied together. So I have a total of 6 to the 11th power. And hopefully you agree this is much simpler than the original statement. Okay, letter B. I have different bases. I have a 3 and a 4, or I'm sorry, a 3 and a B, but my power, my exponent, is the same, 4 in both cases. So I can take this and kind of combine my bases using this property, the power of a product property. So I have 3 times B and the whole thing to the 4th power. By the way, just so you're aware, it would actually be wrong to write it like this. This statement and this statement are not the same. This bottom statement says you have 3 times B to the 4th. If I would expand, 3 times B, 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 B. This is not what we should have. This top statement says you have 3B to the 4th. So you have 3B, 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 3B. And this rearranged would give us back to our original statement. But this exponent here on the bottom, this 4, the exponent is only on the B. It is not on the 3. So I just want to make that point clear. It comes up a lot each year as we're starting to learn about exponents. We make that mistake, and I'll probably mention it quite a few more times. Letter C. Ooh, I've got a negative exponent and a positive exponent. Well, the base is the same, 3, 3. And since I'm just multiplying them together, I can add the exponents together. Okay, so that's going to give me 3 to the negative 2 plus 2, negative 2 plus 2, which is 3 to the 0, which is 1. So this is using the zero product, or the zero power property as well. Lastly, let's see. Well, I'd like to get rid of this negative. I'm going to move that whole term up top. So I'm going to have 5 to the 6th. If I move this whole piece to the top, I'm going to have times by 7 to the 6th. Now I have two different powers with the same exponent, so I can combine the bases together. I can get a 5 times 7 to the 6th. And 5 times 7, well, that's just 35. So in each of these problems, we had to use the properties we were given, the properties we know, to simplify, to make sure we don't have any negative exponents, and to basically just take the information and scrunch it as much as possible, get rid of some of the extra useless pieces, like having two different exponents when we can have one exponent. Or in this case, it means clear to see, here we have 3 different exponents where our final answer, simplified, only has 1. Okay, so I've done these first 4. What I'd like you to do is I'd like you to pause the video. I'd like you to try these next 4. When you're ready to continue, hit play, and we'll go through it together. Okay, here we go. So in letter E, I would take this piece here. 7 to the power of 0 is 1. 2 times 1 is 2. And we could, I guess, leave it like this. I mean, we're talking about exponents. If you really wanted to simplify farther, I mean, 2 to the 3rd power is 8. But we didn't really multiply it in the last problems. Like here we had 35 to the 6th and 6 to the 11th. We didn't multiply. But, I mean, if you want to, I suppose you could multiply. But this is the simplified with exponents. Letter F. Well, I have a negative. I don't like that. But my powers are the same. My bases are the same. So I'm going to start by adding the exponents together. So I have 6 to the negative 5 plus 3 gives me 6 to the negative 2. Okay, so now I'm down to only one exponent, but my exponent's negative. That's no good. So I'm going to take that and I'm going to pass it over the fraction bar, and make it a positive. So my 6 squared is going to go on the bottom, positive, and on the top of the fraction bar, I'm going to have a 1. So I have 1 over 6 squared. Letter G. Let's see. X squared to the 8th. Okay, that one's simple. That's just a power to an exponent, or a power to a power of a power. So that's just you multiply the exponents together. So x to 2 times 8 gives me x to the 16. And then big ugly h. Let's see here. Well, what if I rearrange here a little bit? If I put my 4s together and my 5s together. So I have 5 to the 7th times 5 to the negative 3 times by 4 times by 4 to the 3rd. Okay? So the 5s here, I can add the exponents together, giving me 5 to the 7 plus negative 3 is 4. And here, 4 to the 3rd, and this would be 4 to the power of 1. If you don't see an exponent, it's always to the power of 1. So that's combined together gives me 4 to the power of 4. And look at that. We have the same exponent with different bases, so we can combine the bases together, get me 5 to the 4, or 5 times 4 to the 4th. And 5 times 4 is 20 to the 4th. And there we have our finely simplified answer. This big ugly mess simplifies down to 20 to the 4th power. If you need to review the video, go back and check out some of these problems again to make sure you're understanding the concepts behind the problems and the different properties. I recommend you do it. This is not something that I would spend one day on and think you got it. It's going to take practice to make sure you understand. But let's look at some applications. It says the side lengths of a square are x to the 3rd power feet long. So let me draw myself a square here. So each side is x cubed feet. The formula to find the area of a square is area equals the side length squared, where s is the side length. Okay, length of each side. Write a simplified variable expression for the area of the square. So they're not actually telling us what x is. They're not asking us to find it. They want us to write a simplified variable expression. So the side length of my square is x cubed, and that side length is squared, so I'm just going to simplify this. And a power to a power, I just multiply the exponents together. That gives me x to the 6th power. And that was pretty easy. Next says, the volume of a cube can be found using the formula v equals s cubed. This sounds very similar to the last problem. Okay, so let's see. We got ourselves a cube. Boom. Okay, and volume formula s cubed. All right. Cube A has side lengths of 5 squared centimeters. So each side is 5 squared centimeters. Cube B has side length 3 cubed centimeters. So 5 squared, 3 cubed. Okay. Write the ratio of the volume of cube A to cube B. So the first thing we have to do is, if they want a ratio of the volumes, meaning I want to have volume of cube A over volume of cube B. This is the ratio that they want, right? The ratio of the volume of cube A to cube B. I need this as my final answer, except I need to know what those volumes are. So for cube A, the volume for cube A is going to be side length cubed. I'm just writing down the formula. And we know each side is 5 squared. So the volume of cube A, let's see, 5 squared cubed, you multiply those exponents, giving me 5 to the 6th power. Okay. I'm not sure if I need to go farther than that yet or not. Let's start with B. Volume of cube B, same thing, same formula. So we're talking about volume. And 3 to the third to the third. So volume of B is, I multiply my exponents together since it's power to a power, 3 to the 9th power. And I suppose since we haven't been really multiplying out our exponents yet, I don't think we need to in this problem. So I'm going to say my ratio here, if I actually just substitute my values in here, the ratio of volume of cube A is 5 to the 6th over the volume of cube B is 3 to the 9th. So there is my ratio of the volume of cube A to cube B. Volume of cube A, volume of cube B as a ratio. Volume of cube A, volume of cube B as a ratio. And I'm done. I would like you to try this problem on your own. Please pause the video, try the problem. When you're ready to continue, hit play, and we'll go through it together. Okay, it says the ratio of 2 drill bits is 4 to the negative 5th power. What is this ratio using only positive exponents? Okay, so 4 over 4 to the negative 5th. So the first thing I'm going to do is I'm going to take this whole piece and I'm going to move it to the top because I want this negative exponent to become positive. So that's going to give me 4, and this guy goes up top, so 4 to the 5th. And down here, I would just, honestly, I'd have 1. That would be what's on the bottom of the fraction. But if you ever have a fraction just over 1, you really don't need that bottom part. This looks like it can simplify even more. That's 4 to the 1st power and 4 to the 5th power. They have the same base, but different exponents. So I can add the exponents together. So 4 to the 1 plus 5 gives me 4 to the 6th power. Here's one more for you to try. It says your friend is trying to simplify the expression 5x squared to the negative 4th power. Explain to your friend how to simplify the expression using only positive exponents. Be sure to explain when you are using a property. Okay, so go ahead, pause the video, do the problem. When you're ready to continue, hit play, and we'll go through it together. Okay, so here's what I would do. I would probably, well, I guess let's just start. 5x squared negative 4th. first thing I would do is we're going to have to multiply these together because I want to get rid of these parentheses. So I'm going to take my 5x squared to the negative fourth, which is going to give me 5x to the negative 8. Now, something we haven't talked about a lot, this x squared to the negative fourth, we got that. I think that part's pretty clear. What you may not know is if you did this on your own, this 5 actually should be to the negative fourth power as well. You go, why? Why would you have to? Well, over here, the x is squared, so 2 times negative 4 is negative 8. But the 5 is the power of 1, and 1 times negative 4 is negative 4. So this property we used to get here is the, make sure I have my name right, it's when you have the exponent to an exponent, power to a power, there it is, power of a power property. So we used the power of a power property. Now, because we don't want any negative exponents, we need to get rid of them. So we want to get rid of negative exponents. So to do that, we're going to use the negative exponent property, which tells us if you have a negative exponent, if you pass it over the fraction bar, it becomes a positive exponent. So there's my fraction bar. So I'm going to get 1 over 5 to the 4th times x to the 8th, and that is the negative power property. Or is it negative exponent? Negative power. The negative exponent property. And I think we did everything we needed to do. Let's see, it said, your friend is trying to simplify the expression. Explain to your friend how to simplify the expression. Using only positive exponents, check. Be sure to explain when you're using each property. So we use the power of a power property to get rid of the parentheses. We want to get rid of the negative exponents. We use the negative exponent property to move the powers on the bottom, and they become positive. If you could please, in the summary box on your note sheet, answer this question. It says, how do you use properties of exponents to simplify expressions? Pause the video, do it on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, and here's what I came up with. I said, using each property helps you to combine expressions with multiple exponents into their smaller, simpler expressions with fewer exponents. And it's true, that's what we did. In each of the problems, we took a problem that had some big, ugly, or lots of steps with many exponents, and we combined them into problems with maybe only one exponent. So here we had 2, we're down to 1. Here we had 2, down to 1. But not every problem ends up with only one exponent. Sometimes you might end up with, like in this problem, with 2 different exponents, and that's fine. The other part I said here is they also help you to give only positive exponents. And that's going to be a major expectation for almost every single problem with exponents. Is most problems you want to have positive exponents in your answer. And the zero or the negative exponent property helped us do that. This has been lesson 1.3. Thank you for watching. Bye-bye.